In this video, we're going to go through Lewis structures, and we're going to answer the essential question: how do Lewis structures visually represent the valence electrons of elements and ions, and what are the steps to accurately draw them for atoms and ions? So what's a Lewis structure? Well, they're diagrams that show the number of valence electrons. The number of valence electrons is equal to the main group number on the periodic table for the version that I use in my classroom. When we draw Lewis structures, one dot is going to be equal to one valence electron. And remember, valence electrons are those outermost electrons. So valence electrons are outer electrons. So if I have an atom here, valence electrons are the electrons in the outermost shell on an atom. Okay, so the steps. We'll begin by writing the element symbol, and we'll pull that from the periodic table. So for example, magnesium would be Mg, sodium would be Na. Then we'll look at the number of valence electrons. And again, we can pull that from the main group number on the periodic table. I'm going to be using p-table, and I'll show you how to count valence electrons. We'll place one dot on each side of the element symbol until all dots have been placed. We don't want to pair our dots until all four sides have one dots. That'll make a little bit more sense when we get into an example here. All right, so let's do nitrogen, aluminum, and selenium. So first step, we draw the symbols. So I have nitrogen, I have aluminum, and I have selenium. Let's start with nitrogen. So going from left to right, we're going to count the peaks. So we're going to ignore this middle section, our D block on the periodic table. So if I count from left to right, this would be 1, 2, go all the way across, 3, 4, 5, 6, 7, 8. Those are the number of valence electrons. So here's nitrogen. So going from left to right, 1, 2, all the way across, 3, 4, 5. So nitrogen has 5 valence electrons, so it's going to get 5 dots. And if you recall from our list of rules here, we're going to place one dot on each side of the element symbol until all dots have been placed. So it has 5 electrons, 5 valence electrons, so it's going to get 5 dots. 1, 2, 3, 4. So every side gets one dot. Now I can start to double them up. 5. Okay, let's go ahead and do aluminum next. So, oops, I meant to switch to my periodic table. So aluminum is right here. So again, we're going to count from left to right. 1, 2, all the way across. Aluminum is in the third peak here, group 13. So it's going to get 3 valence electrons, or 3 dots. So 1, 2, 3. And it's okay that that left side doesn't have any dots. All right, selenium, Se, is right here. I'm going to actually count backwards. So I know this last group is 8, 7, 6. So it has 6 valence electrons. 1, 2, 3, 4. Now I start to double them up. 5, 6. That's selenium. So those are atoms. Now, when we do ions, metals lose electrons. So remember, we have our staircase on the periodic table. Metals are going to be to the left of that. Nonmetals are going to be to the right of that. Metals lose electrons, so they shouldn't have any dots. Nonmetals gain electrons. They're going to have a total of 8 dots. Ions are going to go in brackets, and we're going to put the charge outside the brackets. So let's do the ions of nitrogen, aluminum, and selenium. Okay, so we know that nitrogen has 5 valence electrons, but here it has a charge of -3. So it is going to lose 3 electrons. I'm sorry. Let's do that again. It's going to gain 3 electrons because it has a negative charge. So it will have all 8 dots. 2, 3, 4, 5, 6, 7, 8. It's going to go in brackets, and I'm going to write that charge on the outside. So it's -3. Okay. Now aluminum doesn't have a charge of -3. Aluminum is a metal, so it'll actually be +3. So because it is losing electrons, it will not have any dots. And we're going to give it a charge of +3. Selenium has a charge of -2. So it's gaining electrons, so it's going to have all 8 dots. We're going to put it in brackets, and then it will get its charge written on the outside, which is -2. So you will either have all 8 electrons, such as nitrogen and selenium, or you will have no dots if you're an ion, like aluminum, which was a metal. It lost electrons. And that's it. That's how you draw Lewis structures.